Okay, so we're looking at question 2 here, okay? In question 1, we looked at a bar chart, okay? A bar chart is really, really good for counting frequency, okay? It's good when we have numbers that are repeated, and our goal is to find out how often something happens. If you look at the data in question 2 here, we probably wouldn't want to use a bar graph for that. If you're not really sure why, you might want to pause this for a second and look at the data. Remember what a bar graph does. It counts frequency. If we used a bar graph for this kind of data, we would end up with a lot of really just short bars. We would have a lot of bars that were only one high because we don't have a lot of repetitions here. So when we're trying to display data like this, a bar chart probably wouldn't be the best choices, okay? A stem and leaf plot would be a better choice for this. Now, your stem and leaf plot is not filled in. I have filled these in based on the data that we have. Now, how do we make a stem and leaf plot? Basically, we're going to create a little bit of a division here between what we call the stems and what we call the leaves. Okay, the stems in this case are the tens place, and the leaves are going to be the ones place of every individual value that we have. I went through on the left and just sort of filled the leaves in as I saw the data. So for 63, I entered a 3 here because that's the leaf that goes with the stem 6 to make that data point. I entered a 7 because that's the leaf that goes with the stem of 6 to make 67. I went on and did that for all of the data, okay? And you'll notice that it's looks a little bit weird because it's not in order. So I took the same data and over here on the right, put the values that I had in order. That's just a little bit better organized to see, okay? In the second plot, that's where I put them in the numerical order. Now, I will suggest that anytime you're making a stem and leaf plot, that you use graph paper or some sort of sketch paper so that your numbers are evenly spaced. If not, when you start trying to look at the distribution of the data and the shape of the data, it's not going to be as easy to see if you don't have them spaced equally, okay? So also something's missing on here that I usually encourage all of my students to put on a stem and leaf plot, and that's what I call a key, okay? Somewhere over here, over to the side or on this graph, I might put 3 vertical /3 and put equals 33, just so that my reader is clear that the stem represents tens place, okay? It is possible to use stems as hundreds or as thousands. So having a key somewhere on your graph is real important to making sure that your reader understands what your stems represent and what your leaves actually represent, okay? So let's kind of keep going with that. I'll go down to part C. If I use this data, and this data, by the way, comes from someone's perception of a minute. So in other words, if we took away your watch, we took away clocks, and we ask you, okay, starting now, I want you to tell me when you think a minute has gone by. And we actually timed that. That's what these results are the number of seconds it took for someone to think that a minute had passed, so a perception. And it asks us, what is the minimum number of seconds estimated to be a minute? That would be 33, okay? What's the maximum number of seconds estimated? That would be 86, okay? Very easy to see from my stem and leaf plot. How many people guessed 52? 1, 2, 3 people did that. We do repeat these, by the way. If you have 3 people guess 52, there have to be 3 individual leaves in there for that. How many of the estimates are between 52 and 68 inclusive? That does just mean includes 52 and 68. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 inclusive. How many people's estimates were more than 5 seconds away from a minute? Okay. So if we think about that, a minute is 60 seconds. So 5 seconds less would be 55 and below. 5 seconds more would be 65 and below. Okay, so 1, 2, 3, 4, 5, 6, 7 below, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 above. So 17 were more than 5 seconds away. How many estimates were within 10 seconds of 1 minute? Okay, so if they're within 10 seconds, they're going to be anywhere from 50 to 70 seconds. Okay, so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 again would be within 1 minute. Were people's estimates typically too long or too short? And explain your reasoning. So let's kind of think about that. What might you want to base that on? Okay, here's 60. We might want to think about how many people overshot and how many people undershot. If you actually counted that, you would see it's kind of almost about equal. 11 were too short and 13 were too high. So it's about even there. What's a typical number of seconds estimated to be a minute? And explain how you chose your number. Okay, so again, a lot of us might have some different ways we would pick that. If it were me and I were looking at this, I might say 52. Okay, for a couple of reasons. It seems to be somewhere here in the middle of the data. Okay, it's not the extremely short and it's not the extremely long. Also, it's the most frequently expressed guess. So I would guess it's somewhere near the middle, and it's also the most frequent. So for me, that's why I would pick 52. I think most of you would probably say the same. Okay. However, I have many students who might argue with that. You know, it's on the lower end. It's not necessarily around 60. Remember, we're not trying to figure out if they guess most accurately. We're kind of asking what is the most frequent guess or what is the most typical guess that people made in terms of how long a minute lasts. So if we went on to F, it asks us, how would you describe the shape of this data? Okay. It is clumped in the middle. Okay, we do kind of see a little bit of a bell shape going on here, but it's not very symmetric. Okay, we do have most of the data in the center, but we have more frequency in answers on the upper side than the lower side. So I would say that this data is clustered around the middle, but it's not symmetric. It doesn't also appear to be skewed. We don't have a lot more lows than we do highs. We said that was about evenly split. So just clustered around the center, but not symmetric would be my description for that data.